Breakthrough: Understanding the Impact of Satellite Constellations on Astronomy. I'm Steve Belair. Welcome to Breakthroughs. In June 2019, the International Astronomical Union expressed concern about the negative impact that the planned mega-constellations of communication satellites may have on astronomical observations and on the pristine appearance of the night sky when observed from a dark region. We here present a summary of the current understanding of the impact of these satellite constellations. Following the statement of June 2019, IAU's Commission B7 Protection of Existing and Potential Observatory Skies and the Executive Committee working on Group Dark and Quiet Sky Protection were asked by the IAU Executive Committee to assess the situation and to start discussing with the companies that are responsible for launching and operating the mega-constellations in order to study measures to mitigate their interference. Commission B7 has requested the input of astronomers from different organizations skilled in modeling the frequency, location, and brightness of satellite mega-constellations. The results of the simulations, given the large number of parameters involved and the associated assumptions and uncertainties, are to be considered preliminary. While there is a large uncertainty about the future number of satellites, some of the simulations were conducted on the basis of a large sample of over 25,000 satellites from representative satellite constellations from different companies. With this sample, the number of satellites above the horizon at any given time would be around 1,500 to a few thousand, depending on the latitude. Most of these will appear very close to the horizon. Only a few of them passing directly overhead. For instance, about 250 to 300 would have an elevation of more than 30 degrees above the horizon, where the sky is clear from obstructions and where most of the astronomical observations are performed. The vast majority of these will be too faint to be visible to the naked eye. When the sun is 18 degrees below the horizon, i.e. when the night becomes dark, the number of illuminated satellites above the horizon will be around 1,000. with around 160 out at elevations above 30 degrees. The number decreases further towards the middle of the night when more of the satellites are in the Earth's shadows. At the moment, it is difficult to predict how many of the illuminated satellites will be visible to the naked eye because of the uncertainties of their actual reflectivity. Also, since experiments are being carried out by SpaceX to reduce the reflectivity of a Starlink satellite by adopting different coatings. The appearance of the pristine night sky, particularly when observed from dark sites, will nevertheless be altered, because the new satellites could be significantly brighter than existing orbiting man-made objects. The interference with the uncontaminated view of the night sky will be particularly important in the regions of the sky close to the horizon and less evident at high elevation. The prominent trains of satellites, strings of pearls, often seen in images and videos, are significant immediately after launch and during the orbit-raising phase, when they are considerably brighter than they are at the operational altitude and orientation. The global effect depends on how long the satellites are in this phase and on the frequency of launches. Apart from their naked eye visibility, it is estimated that the trails of the constellation satellites will be bright enough to saturate modern detectors on large telescopes. Wide-field scientific astronomical observations will therefore be severely affected. For instance, in the case of modern fast wide-field surveys, like the ones being carried out by the Rubin Observatory, it is estimated that up to 30% of the 30-second images during twilight hours will be affected. Instruments with a smaller field of view would be less affected. In theory, the effects of these new satellites could be mitigated by accurately predicting their orbits and interrupting observations when necessary during their passage. Data processing could then be used to further clean the resulting images. However, the large number of trails could create significant and complicated overheads to the scheduling and operation of astronomical observations. A summary of the findings and of the actions that have been so far undertaken is presented in a specific IAU theme. The focus of this statement has been on the optical wavelengths. This is not to underplay the effect of radio and sub-millimeter wavelength ranges, which is still under investigation. The IAU considers the consequences of satellite constellations worrisome. They will have a negative impact on the process of ground-based astronomy, radio, on optical, and infrared, and will require diverting human and financial resources from basic research to studying and implementing mitigating measures. A great deal of attention is also being given to the protection of the uncontaminated view of the night sky from dark places, which should be considered a non-renounceable world human heritage. In order to mitigate the impacts of satellite constellations that may interfere with professional and amateur astronomical observations, the IAU, in close collaboration with the American Astronomical Society, will continue to initiate discussions with space agencies and private companies that are planning to launch and operate currently planned and future satellite constellations. The IAU notes that currently there are no internationally agreed rules or guidelines on the brightness of orbiting man-made objects. While until now this was not considered a priority topic, it is now becoming increasingly relevant. Therefore, the IAU will regularly present its findings at the meetings of the UN Committee on Peaceful Uses of Outer Space, bringing the attention of the world government representatives to the threats posed by any new space initiative on astronomy and science in general. The IAU stresses that technological progress is only made possible by parallel advances in scientific knowledge. Satellites would neither operate nor properly communicate without essential contributions from astronomy and physics. It is in everybody's interest to preserve and support the progress of fundamental science such as astronomy, celestial mechanics, orbital dynamics, and relativity. Whew! I'll leave a link in the description to the full article, and as usual, please like, share, subscribe, and take care.